Welcome to the SMARTFIRE demonstration. SMARTFIRE is the fire field modelling environment developed by the Fire Safety Engineering Group at the University of Greenwich. If you'd like more details, please email to smartfire@gre.ac.uk. I'm just going to fire off the first component of our environment. That's a scenario designer into which you can load DXF floor plans or images of floor plans. Here I've chosen to load the floor plan of our library building, and I'm now setting a grid size for the Snap to grid. I've just noticed that there's an item in the DXF plans which will hamper finding the rooms, so I'm going to disable that item. Now I'm going to select the story or area that I'm going to include in the CFD simulation. And now zoom in on that area. And I'm now going to start to add objects. Here I'm using the automatic room finder to find most of the rooms. It doesn't find all of the rooms, and it doesn't necessarily find the rooms perfectly accurately, although there is an editing tool to enable me to change the sizes of the rooms, as demonstrated here. I can also edit the rooms manually back in the main editing window. And of course I can add additional rooms using the object editing tools. So the corridor, which was missed because of the large number of doors and the open end, I can add manually. I'm now going to add a fire to the large room, although I'll configure this in a later tool. As well as finding the rooms, I need to add doors. There is an automatic door finder. I'll just show you that in operation. But unfortunately I don't really want to use those doors for this particular simulation. So I'm going to manually add the doors that I want to appear in the simulation. The exterior openings in the geometry, which are actually windows, I'm going to choose to be closed during the simulation. So here I am adding doors to the central corridor and linking the rooms together. Again, you can manually edit the sizes of the objects. And I'm adding a partition or two to more accurately represent the geometry, particularly in areas where you know that there's going to be some flow. I'm going to choose to make this building multi-story, so I'm going to link the stories together with stairs. But because I want the simulation to run quite quickly, I'm going to choose to have only a few stairs representative of what will be in the real building. This cuts down on the mesh budget requirements. I also need to link the stories together using an opening. And I've now added the geometry to my scenario. I'm now going to clone this story, and because I want the stairs to wind up through the building, I'm going to adjust the stairs and change their properties so that the direction is consistent with that. And I'm going to move the opening so it's above the new stairs. And I'm going to add a window at the end of the corridor. Just to check, I add the geometry now entered into the scenario. Before moving on to create the final story. In this story I won't have any more stairs going up, so I delete the stairs and the opening. And finally I add this geometry to the scenario. Now you see the 3 stories. It's also a very good idea to check the geometry using the Explorer. And here I'm going through the geometry, looking at it in 3D mode, in order to check that all of the features that I want to appear in the CFD simulation will actually be there. I can now save my building. This will allow me to come back and edit it later if necessary. And now I'm going to create SMARTFIRE simulation. And this will allow me to move on to the next tool in the SMARTFIRE environment, the case specification environment. So here we see the case specification environment has automatically loaded and our geometry is now included. And in this tool the emphasis is now on the objects creating the partitions between the rooms, the walls, portals and the fire instead of the rooms. This allows detailed physics configuration of those objects. Now see the problem type options and some of the submenus. I'm going to activate the radiation model, the combustion model. These menus are usually configured with sensible defaults, and I'm going to activate the smoke model. It's also possible to change the solution control, including control of number of sweeps, time step size and total simulation time. You can also change some of the default physical properties for the scenario, and I'm setting the default wall thickness to 0.2 meters. I'm now going to edit the fire properties, and this is a fuel generation rate in kilograms per second, and I'm going to set the end time for the ramp up to 100 seconds and enter an expert t-squared parameter of 1e-5, which gives me a fuel release rate of 0.1 kilograms per second. I could set other properties as well, although I'm going to choose to use the defaults for this case. There are a number of other options within the software, including optimizations. and I'm going to choose to set the output controls so that less data is saved. Only the data that I'm particularly interested in, for example temperature, smoke and the velocity components, rather than everything that is calculated. And quickly save the case so that I can come back and edit again if necessary. And now I'm going to run the automated meshing system. The meshing system attempts to analyze what type of geometry has been entered, and in this case it thinks correctly that it's a multiple story building geometry. I'm now going to edit some of the meshing parameters in order to ensure that my particular mesh is going to use as few cells as possible, because I want it to run quickly for this demo. I'm going to disable some of the extra layers which would normally be created. And then the software tries to work out where extended regions are needed, and I'm going to choose to ignore its recommended. And now we arrive at the cell budget. I'm just going to choose to use a coarse mesh without refinement, although it's possible to use more cells and get a more accurate solution for your production run. The menu also has options for iterative refinement, so that cells are made to adhere to cell quality metrics. There are a couple of small blocks which I'm going to choose to remove. And then we see the result of the meshing. This coarse mesh isn't ideal because so many rules have been disabled. So the tool also allows you to manually add cells to any blocks which appear to be too lightly filled with cells. Here I'm choosing very coarse meshed blocks and adding a few cells. And now I accept the mesh, and this will generate the script file and the geometry for use in the CFD engine. I now choose to run the CFD engine, and this starts to load the files that I've just created, load the geometry, initialize some memory, and perform the initial setup. Once this is complete, the main user interface will open. And I'm now going to choose to select a different visual for the runtime visualization. I'm going to choose a Y plane. It's a horizontal cut plane. And I'm going to show a temperature fill on that plane. So this will be through or just above the fire. And here we see the cut plane through the geometry. So you can now run the CFD case. And you now start to see the simulation building up in the visualization window, as well as graphs of residuals and monitor data appearing in the status window. The status window is also showing that this simulation is going to take approximately 7.5 hours. At any stage during the simulation, you can actually stop the code and then use the menus to reconfigure any of the settings that are available, including things like choice of solvers, numbers of iterations, tolerances, etc. I've moved on in time now so that we can actually examine the data in a bit more detail. Here I'm going to choose a Y-plane on the same floor as the fire. And I'm going to activate the visibility tool, which allows you to interactively check out the visibility distances on a particular plane. Here you see I'm moving the eye tool around, and the green rays show how far, in theory, I'd be able to see. On this fire plane there's an awful lot of smoke, so I'm not able to see very far. If I move the cut plane up now to the second floor, and move the eye point, you can now see that you can see considerably further. I'm going to change the visualization now to a vertical cut plane through the fire. And you see that the visualization has changed. SMARTFIRE also has plot definition tool, whereby you can draw an arbitrary number of plots during the simulation. This data can also be output. It's very easy to change the start and end location of the graph, and also what would be saved. SMARTFIRE has an interesting feature, which is the Data Explorer. I'm just going to resize this window so you can see more of the options available. The Data Explorer allows a point to be moved around inside the domain, and this shows the cell data at that particular point for all of the variables that are being calculated or solved. There is also a locate feature, which means that the software can hunt for the cell that has the minimum or maximum value, or even the maximum residual. Obviously this point can be manually moved around as well, and you see the data change to reflect that new location. Just checking the capture options here. Many options for saving data in a variety of forms. SMARTFIRE also has a bookmark and restart facility. This allows you to make changes to a simulation, and if those changes cause a problem, you can restart and go back to a safe point in the calculations. Now going to fire off the data view program and load up one of the data sets that's been created. First to load is the geometry, and here we see the 3-story building. Just going to zoom in on that to get a better view. Now I'm going to open one of the data files that contains the temperature, smoke and velocity information. And first up is a scalar visualization isosurface of smoke. By changing the contour value, you can see different isosurfaces, and it's also possible to have multiple isosurfaces. Here we see the concentration is quite low and coming back down to higher concentrations. This is now an end view of the geometry, and you see the lower concentrations going up to the 2nd floor and beyond. Now I've activated the vector view, and this is showing the vector cut plane being moved backwards and forwards through the data. And the tool also has the ability to load in a collection of data files to create an animated movie of whatever is on the display. Because I haven't finished the simulation yet, I'll actually run an animation that I've previously created for a very similar case. This time we're seeing isosurfaces of temperature and smoke concentration, which is the green shaded quantity. You see the smoke now spreading up the stairs to the upper floors. Well, that's the end of the demo. Thank you very much for watching, and if you need to contact us, please do so at smartfire@gre.ac.uk or by ringing 44208 331 8730.